In the last session, we discussed about NAT and HSRP, right?
Sir,
Yes, sir.
can you share the screenshot of the HSRP configuration?
Which one?
HSRP configuration.
HSRP configuration.
Yes, sir.
Yes. Yellow color.
Okay.
Front side, huh?
In the HSRP configuration, you are having only 3 commands, right?
Yes.
The dynamic NAT and PAT configuration, you guys have done it, right?
I tried, but I couldn't do it, sir. That's why I want.
No, the dynamic NAT.
Yes, sir. HSRP, sir. I need HSRP configuration.
Okay. This is your gateway 1.
Repeat.
Show running config. Okay, this is the part. This, like what? This is your group ID, group number, then virtual IP, the priority 54, and preempt.
Yes.
Okay, priority wise, this is where exactly it will be 255. Otherwise, everything remains same.
Yes.
Okay, in gateway 1. And we are configuring this HSRP on these ports. Okay. So this router configuration will be this
255.
only. Instead, it will be what? 250?
255.
255.
And FH01, sir. FH01.
FS01, this is your normal configuration. The IP address configuration you are having, right?
Yes. That
The
means
basic configuration.
IP address 70.0. Then after no shutdown. Okay.
And we are running any like what routing protocol. Here
Yes.
I'm running an IP.
Yes, sir.
If you want, you can run HLP or OSPF.
Yes. So, sir, what we have to configure at the router 1, sir?
Router 1, this is your normal basic IP configuration on these 2 ports and the protocol itself. That's it.
Okay, sir.
Okay, so HSRP, we are doing it on our LAN on this side. Okay, here we are configuring HSRP. On internet side, we are not configuring it. Because from ISP, we are getting the connection, right? Anyways.
Yes.
Understood?
Yes, sir.
Okay. This is the concept what exactly we are having today. That is your WAN technologies. And later we'll cover the switching technologies if time is there. Anyways, this is what we are having the topology right now, everyone. Very simple topology with just 3 routers. You can see that I'm using something like a serial link over here. Can you see this? It's a serial link. These serial links always are used in wide area network technologies to connect your routers. Most of the time, your ISP, when they provide internet connection to you, let's say that this part is your ISP and this is you. So basically, this is the customer. Customer router, that is your company's router. And when they take internet connection, ISP basically provides this connection by this type of links, serial links. This is what we call point-to-point connection, everyone, PVP, point-to-point. Okay. Point to point. Point-to-point connection. Why point-to-point connection? Because one point of the connection is connected directly to the ISP router, and one point of the connection is directly connected to the customer router. That is your company. Company. Okay. This type of connection is also called as leased line connection as well. Leased line. Leased line connection. Okay. What you are having over here. So this type of connection, it is super costly. Why it is costly? Because your router is directly connected to the ISP router itself, okay, over this connection, and you get dedicated bandwidth. Bandwidth, that is basically your speed. Dedicated bandwidth. Okay, let's say 1 Mbps, 2 Mbps, okay, 100 Mbps, like that. You are getting dedicated bandwidth on this particular link. Means whatever your ISP is telling you, okay, or is giving you the speed, at that particular speed you can do the transmission, you can do the reception of your data. And that is the reason this particular line is super costly. Because if they are telling you that 1 Mbps bandwidth you are having to transmit or receive, always it will be 1 Mbps only. Okay, it will not go below 1 Mbps for you to transmit or receive information. Minimum 1 Mbps you will be getting. But this type of links, we are having two sides. One is called the DCE side, DCE, and one is called the TTE side. Now, DCE and DTE basically stands for what? DCE stands for data channelized equipment, and DTE stands for data terminal equipment. Data channelized equipment and data terminal equipment. This one always, this particular side, the DC side, always belongs to ISP. And this side always belongs to the customer. Means the company to whom exactly this connection is given, that is the DTE side. Okay, on a serial cable, always you got these two DC and DTE sides. So ISP side always belongs to the DC, and the DT side always belongs to the customer. Always. That is how they give their connections. So how do you get this type of links? Basically, we have WIC module, which is your one interface card module, which provides us the serial ports. You can see that we're using serial as 0/3/1, all these ports. Normally, when you take your router, you basically don't get this type of serial ports. Okay, if you purchase any Cisco router, you will never get a serial ports in it. This type of serial ports, you can get it with this module. Now, this module, you have to purchase it. Okay, there are WIC module available, which you can purchase it in order to use these ports to connect over a serial link. So this module you can basically have it in the packet tracer. If you see these modules over here, this is your module. It is the latest one on serial, that is WIC23. This module, we need to install it into these slots. These are basically called as slots. So once you install this module into these slots, this is when you are getting the WIC port. This is your serial. So all you have to do is switch off your router, drag this module from here and install it over here. So right now you can see the definition of this particular module. It is available over here as well. And this particular picture of this module is available over here. So you can see this is one port and this is another port. Okay, so it is giving you two serial 1 interface ports on your router to connect over a serial link. And in this manner, if you simply just go to config, you can see that right now we are having two ports available. So these two ports always you can use in order to connect your serial pins. This is the way we have connected our routers in this particular topology by installing this module, WIC module. And the cable what we are using is this cable. You can see this DC cable. This is a DTA cable. So DC cable we are using it to connect our ISP side to the customer side. But whenever we make communication over a serial link, always encapsulation, it must be configured. Without this, you cannot do. The default encapsulation protocol, what is used on a serial link is this one, SDLC, which is a Cisco proprietary, means this must be a Cisco router, and this must be a Cisco router if you want to configure. By default, on all Cisco routers, the encapsulation is SDLC. So every single data, whatever we are sending over a simple serial link, this data, it needs to be encapsulated with SDLC encapsulation. Okay, because these are Cisco routers, and by default, this is the encapsulation which is used to encapsulate your data. When it is getting sent from this side of the link, it is encapsulated. When it is getting received over here, then decapsulation happens. This is when it removes the header and it basically gets the data. But since it is a proprietary one, we have compatibility issues, because when we are considering our ISP routers, they might not be having Cisco routers. Okay. You may not get a Cisco router in the ISP side. Maybe they are using Juniper router. Juniper router. Now, when you are using a Cisco router and when you are using a Juniper router, then this encapsulation, you cannot use it because it is like, but it is not supported on the Juniper one. So point-to-point protocol, this is your PPP, which is considered as an open standard protocol, is basically coming over here in this circumstance. So when you have multiple branch routers, which is connected over a serial link, and you want to run an encapsulation, then SDLC is not a choice for you, but PPP always is coming over here as a as the most popular type of encapsulation what we are using on a serial links between two different companies routers. So PPP is the most used encapsulation protocol over a serial link, okay, because it gives us security related features like authentication. When we are using authentication, this is when we get two types of authentication in PPP. One is called the PAP and one is called the CHAP. The PAP stands for Password Authentication Protocol, and CHAP stands for Challenge and Handshake Authentication Protocol. The difference between both these types of authentication is related to password. Password informations, what exactly is used in authentication, it is in clear text, it is available in PAP, but the same information it is encrypted in CHAP. Because when we do authentication, router 5 will authenticate router 6 and router 6 will authenticate router 5. Both routers will be authenticated. They will verify that whether it is really router 6 who is connecting to router 5, and router 6 will verify that whether it is really router 5 who is connecting to router 6. This is the authentication what we are doing, but for better security. Because on internet always we have the risk of hackers. And this type of authentication, which is provided by a point-to-point protocol, it gives us the flexibility to authenticate the router to whom we are basically getting connected over serial link on the ISP side and do the communication. But the clear difference is coming from the perspective of password, because when we authenticate other routers, okay, so this router is authenticating this router, then this is the username and password, what exactly they authenticate. Username, password. Based on the username and password informations, this authentication has been performed in PPP. And this username and password informations always you have to create in a user database. All these routers, we have to create a user database which contains the router's username and the router's password. And based on this user database itself, this entire authentication process will be performed in PAP as well as in CHAP. So regardless of whichever type of authentication we are doing, whether PAP or CHAP, always this database needs to be created. Now, there is a rule in terms of creating the user database in PPP everyone. And the rule basically says that on router 5, you have to create a user database of router 6. Means router 6 username, username, password, this is what exactly it must be available in router 5 itself as a user database. Means this is what we need to create on router 5. Okay, we need to store this username and password information of router 6 in router 5. And similarly, in router 6, we need to store the router 5's username and password. Okay, username and password. Okay, so on a particular router, we have to store the information that is the username and password of another router. Regardless of whether you are doing PAP or TAP authentication, always this is the process to create your user database and perform authentication in PPP. Similarly, on router 6, we have to create the username and password of router 7. And on router 7, we have to create the username and password of router 6. This is the user database what we have to create in this manner to perform the authentication process. So these are the configurations what exactly we are having over here. If you can see the user database what we are creating, it is available over here. You can see this is the router 5. Okay, so in between router 5 and router 6, we're doing tab authentication. And in between router 6 and router 7, we're doing chat authentication. But but in both these types of authentication, always we are creating the user database. So on router 5, in terms of tab authentication, we are creating the username router 6 password. Now, one thing always remember that the username what we are creating, that is always equal to the host name of the router. The host name of your router, like the host name command what we used to change the router's names. This is the host name which is basically coming as a username. Okay, so if the host name of router 5 is R5, let's say, then this is coming as a username in router 6. If the host name of router 6 is R6, then this is coming as a username in router 5. So this username is router 6 what we are using. This is basically the host name of your router 6. And password we are using. After that, we are going to this particular port and we are giving this command called PPP authentication path, because we have to specify that which authentication we want to do between router 5 and router 6. So first of all, this is the path configuration we are doing. So this is your PPP authentication path is coming. Once you give this command, this is when you have to send your username and your password to router 6 for verification purpose. This is a PPP path sent username router 5. You can see that this router 5 is basically coming over here as a host name and the password authentication as well. So make sure that you use the same password informations when you are creating your user database. These are very much case sensitive. Case sensitive means uppercase, lowercase, all these things it matters. So user database always is created in this manner. Now, if I scroll down over here, this is when you are seeing that on router 6, we are creating the username and password of router 5. So this is the router 5 host name. So this one is coming over here as username. And the password is path. Okay. And after that, we are going to the serial 0/3/1 and PPP authentication path. And we are sending our username and password. So router 6 username, that is the host name of router 6, password and stuff. If you see both these configurations, you will find that here, exactly from here, we are basically doing the configuration over here. This is the same thing what we are configuring. And what we are doing over here, it is the same thing what we are creating over here. Okay. So the main reason of using this command is for router 6 to send its username and password to router 5 so that router 5 can do the verification regarding its user database, okay, or regarding its username and password with the local user database what exactly it is stored in router 5 itself. So in this manner, exactly the authentication is performed, where exactly we are configuring the other routers informations in our user database and we are doing authentication. The same thing over here also is available in the chat authentication, but this chat authentication we are doing it between router 6 and router 7. First of all, we need to create the user database. So username router 7, that is the host name, and password is chat. And here we are simply just mentioning that we want to do chat authentication. This is a very simple configuration what you will have. Okay, like that configuration, this command is not required. You can see that this command ppp perhaps and username, it is not there because we in chat authentication we are not sending our username and password to the other router for doing verification. Chat automatically does this verification in the background. We don't have to send explicitly our username and our password to other router to do the verification. But in PAP it is required. Okay. In chat, always the user database and password you have to create, but this command is not required. This command. Okay. If you simply just mention the chat authentication, then this chat authentication will automatically verify the username and password informations from the user database. Automatically, these things happen. That is why if you just mention the chat authentication over here, you don't have to mention any other thing. Okay, not like the PAP configuration. So all of you simply just take the screenshot of this. Take the screenshot of this. Taken.
Yes, sir.
Take the screenshot.
Yes, sir.
Taken, right? Okay, and this is the chat configuration. Finished?
Yes. Yes, sir.
Yes, sir.
Okay. Now once you do all this configuration, because my routers are configured with all the chat and PAP configurations, you will be able to see that you have communication over a serial link. Okay, and for that you send a ping. This is my network 100.0.0.0.0.0.1 and this is 0.2, and over here we have 101.0.0.1 over here and 0.2 over here. So we will do the ping test, because if your authentication is working, if it is perfect, it means that you will be able to communicate over the serial link to router 6, and router 6 will be able to communicate to router 7. I'm not doing any routing now. I'm simply just configuring the IP address. Okay. So one thing always remember that on a serial link, whichever side is the DC side, because always we have DC and DT. On the DC side, always you need to configure something called clock rate. Clock rate. This is in bits per second, BPS. We have to specify. Now, this particular side we are considering as ISP, because this DC side always belongs to ISP, and ISP always sets this clock rate when they're giving the connection to the customer. This the main reason why we are using this clock rate is for synchronization of your data. For synchronization of your data means whatever information we are sending over a serial link, it needs to be properly synchronized so that the other device can understand it. Okay, and that is the reason this bits per second clock rate is basically set up by ISP on the DC side. So you can see this clock symbol over here. This is the clock symbol. In packet tracer, you can easily identify the DC by this clock symbol over here. And this clock symbol simply indicates that you have to configure the clock rate in this particular port in bits per second. So normally ISP always configures that, because on the customer side we don't get the DC. If you are the service provider, internet service provider, then you will be configuring your clock rate on the port. But normally in the organization, we don't configure clock rate because always our side always is a DT side. This is a DT side. And on the DT side, we don't configure any clock rate. So if I show you the configuration of this ports, everyone, serial 0/3/1, this is your router 6. This is what the configuration it looks like. Show running config. You can see the port is configured with their IP address. The encapsulation is PPP. Then we are doing the PPP configuration, that is your authentication. So this is what exactly we are configuring over here. PPP authentication path and PPP path sent username router 6, password is 1. Okay. This 0 it simply means that it is clear text information of the password. This router 6 username router 6 password path is basically coming from the host name router 6 and the password what we use to do the verification. And lastly, you can see the clock rate command. Clock rate 64,000. That is means 64,000 bits per second. Bits per second. So 64,000 bits per second equals to what? 64 kbps. Kilobits per second. Okay. This is the standard clock rate what exactly is being provided when we are configuring the clock rate. But you can increase this clock rate like what? Exactly in double, like 128,000 bits per second, 250,000 bits per second. Okay, this is totally up to you. But normally 64,000 is the standard clock rate what is given for data synchronization purposes over serial link. This send username router 6 password path. This is the same command what exactly we are creating on router 5 for creating the database. You can see that this particular router so this is the serial 0/3/1. We are configuring the IP address. We are configuring the encapsulation, password, authentication protocol. There is the authentication type. And you can see the username router 5 password is done. Okay. And the user database is created over here in the on the top. You can see this is the username, router 6, password is done. Okay, this is your user database. So this router 6 is coming from the hostname of router R6. And this is the password authentication protocol. This is your router 6 password. What we are using to do the verification. So once it is done, once you have done the configurations and when you ping to 100.0.0.1, which is the router 6 IP, you should see communication is happening. If your authentication, if your user database, everything is perfect, this is the 100% communication you should achieve with router 6. Now between router 6 and router 7, you are doing the chat authentication. Chat authentication is very much easy because over there we just have to mention the chat authentication. You can see this is your port serial 0/3/0. This is the IP address what we are configuring. This is the encapsulation PPP we are configuring on this port, and just we are mentioning the chat authentication. We don't have to mention this command, okay, in chat because chat does all the verification in the background. So the thing, what exactly we're doing over here is we are creating the user database. So this is the user database of router 7. So this is the host name of router 7 and password is Jack. And on router 7, we're doing the same configuration. So you can see we are creating the user database of router 6. Password is Jack. And after that, on serial 0/3/0, since this particular site belongs to the DC, is the clock rate what we are configuring on serial 0/3/0 IP address, encapsulation, and PPP authentication chart. This is the entire configuration of your this port on the router. And once you have done this, send a ping from router 6 to router 7, and you should be seeing communication. So ping 101.0.0.1, and you can see the communication is happening. Okay. So how do you see the encapsulation? Because we're using the PPP encapsulation. How do you see it on a particular port? If you want to see that which port is using what encapsulation on your Cisco routers, you can simply just give this command. Show interface, then the interface number. Okay, suppose you want to check this particular port encapsulation. So S0/3/0, this is what exactly you have to give over here, S0/3/0. And once you give this particular command, it will display all the interface related statistics over here. Okay, so you can see the 0/3/0 is up, line protocol is up, we have connected. This is of the IP address, what we are configuring. The bandwidth is 1544 kilobits, 1544 kilobits, that is equal to 1.5 Mbps of megabits per second. This is how much exactly you are having the speed. On a serial link, always you can transmit or you can receive your informations, okay, at a minimum speed of 1.5 Mbps. This is what exactly is the speed over here. But the main thing you can see, there is encapsulation. Okay, because when we configure a particular port with encapsulation command, and specifically PPP, this is where you get to see that whether this port encapsulation is PPP or not. Because if I simply just take any serial port, let's say that I go to this router. This router is having another port, serial 0/3/1. If I simply give show interface S0/3/1, S0/3/1, you can see that over here, the encapsulation is what? SDLC, right? This is your S0/3/1. This is the encapsulation. This encapsulation by default it is there, okay, on all Cisco routers. Because this router is a Cisco router. Okay, it's a Cisco router. And on all Cisco routers, the default encapsulation is SDLC. Now this SDLC basically stands for high level. High level data link control protocol. High level data link control protocol. Okay, this is what HDLC full form is. And this one is not the kind of flexible enough like PPP, because one of the major function or one of the major feature what this one doesn't provide is the authentication, which is very much required when we are connecting our routers over a WAN link to ISP routers. And that is the reason we don't use HDLC, because on WAN links always we require authentication. So this is what exactly your PPP, okay, encapsulation. It basically looks like everyone. Okay, the way you are configuring it, very simple configurations, nothing complicated. You set up the username, password, you basically go to the port and you define which type of encapsulation you want to use. Then you specify that which type of authentication you want to use. If you are using PAP, then user database password informations you have to create of other routers in your local router. And similarly, you have to send your username and password to the other router for doing the verification. And in CHAP, it is not required because we are simply just creating the user database. CHAP is simply doing all the verification by itself on the background. So only if you specify that you want to use CHAP authentication, all this verification of username and password, it is automatically done by the routers. This is what exactly we're having the PPP configurations, everyone. Understood?
Sir, one question is there.
Tell me.
Sir, like you just now showed the router 7 interface details. So there it is showing encapsulation type SDLC, correct?
That is correct.
But sir, we have configured the authentication type of PPP. So PPP, like you said, it's a completely different protocol. So there also it should show PPP only, no?
See, the thing is, what exactly I have shown you. This is the port serial 0/3/1, which is not used, right? First of all, is it used in your topology? We are using serial F0/3/0, right? This is the port what we are using to connect to router 6.
Okay, okay, then it is.
Okay, here we configured PPP, right?
Okay.
But this one is not used. So by default, when you are not using this port, by default your encapsulation is what?
SDLC.
SDLC. This is what I said, the default encapsulation. When you don't set up the encapsulation, then your serial ports on your routers, on a Cisco router, is using which protocol? This is a Cisco proprietary SDLC protocol, which is used because this is Cisco router. Okay.
Okay, sir. Okay.
Okay, everyone. All of you got it right? This configurations. All this configuration got it?
Yes.
Okay. So Mukul,
Yes.
you have your system on?
Yes, sir.
Then share your screen and set up this topology of 3 routers and do these particular configurations one by one. Between router 5 and router 6, we are doing CAP authentication, and router 6 to router 7, CHAP authentication. Understood?
Yes, sir.
Do this thing, and after that, do the verification using ping command. You know, right, how to get your serial ports?
Yes, sir.
This is the module.
Going to the module and
Two things.
picking the second last.
Okay.
Yes.
So always switch off your router first, then drag the module into the slot, then switch on your router. You will be having ports. Okay.
Yes.
So share your screen, set up this topology. Bhaskar,
Yes, sir.
you have your system, right?
Yes, sir.
Is it on?
Yes, sir.
Do the same project and just tell me the status of it.
Okay, sir.
Okay. Mukul is sharing the screen right now.
Okay, sir.
Go on. Mukul. Mukul is there. Unmute yourself and explain what exactly you're doing, okay? Mukul, you are muted. Unmute yourself.
Am I audible, sir?
Yes, yes, we can hear you. Go on.
Choosing the 3 routers here. Changing the router name. Router 5, router 6, router 7. Now into the router 5 module.
3 routers you have to take. Mukul, 3 routers, not 4.
Okay, sir.
Switch off your router. Switch off your router first.
Switching off the router. Then adding WIC2T. This part. Switching it on. It's starting. Then doing the same to the router 6. Switch off. WIC. Turning it on. Starting. Router 7. Switch off. WIC-T. Switching on. This one also started. Now the wire. Choosing this one. Which serial we have to pick, sir? 03/0, sir, right?
Three one.
3-1. 3-1.
Mukul,
Yes.
this side will be the DC side.
Yes, sir. DC side.
Yeah. This one you should be using over here. Release the cable.
From here I have to do it, sir.
Ah,
Okay. Correct, no?
Yes. Go on and
Configuration. So then enter, then enable, config t hostname router 5. Then username router 6 password path. Then interface SE/3/1 enter. Authentication setting encapsulation.
Mukul,
Yes.
first enable the port number.
Yeah, I've enabled this one and started the configuration.
always configure encapsulation first. Okay.
Means I have to type the IP address.
Yes.
Interface,
See, do it step by step. First you configure the encapsulation, then you configure the IP address. On all the routers, you do encapsulation first.
Okay.
Okay. You configure encapsulation, PVP,
Yes.
on all routers ports. After that, you configure the IP address.
Okay, sir.
Okay. Then wherever it is required, give the clock rate. Then give no shutdown. Authentication you do at the very last.
Okay, sir.
Okay.
IP address.
Just
100.
do one thing. Just do one thing. Restart this router and start it from the very beginning.
Okay.
Restart the router.
Erase. Should I
No
erase
need
it?
to erase. No need to erase. Simply just restart the router. First you go to router 5, router 6, router 7,
Okay.
and give encapsulation to all the ports. Then you configure IP address, give no shutdown.
Means interfacing SE0/3/1, then IP address 100.0.0.2 space, then subnet mask, then do no shutdown. That
no
way I have to.
shutdown. Then after that, you have the clock rate, right? On this side, you are having the clock
Yes,
rate.
clock rate. Yes.
Yes. So finish these commands first.
Okay.
And at last you do the authentication, the user database, whatever you are doing. Okay.
Yes. Enable. Name. Oh. 5. Interface is 0/3/1. Press 100. 0.255, not 0.0. No shutdown. Great. 5,000. Correct, na, sir? Clock rate 65,000.
64,000. 64,000.
64,000 and then enter.
Now this one is not your DC, no? This side is DT, right?
DT, yes,
On
DT.
the DT side, you don't give clock rate. No clock rate.
Hmm.
Clock rate should be given on the DC side only.
Yes.
Okay, that is why you can see that. Can you see this message?
The command applies only to DC interface. Yes, sir.
Okay, so this is not a DC interface, that is why you are getting it. Okay, go on. Encapsulation and set up the encapsulation.
Username, start with the username, sir.
No, encapsulation. The encapsulation command is there, no? Encapsulation PPP command is there or not?
So actually, you haven't shared that screenshot, sir.
The screenshot you have taken, right?
No, sir. Actually, you shared the screenshot of that user database.
See, the
Like
thing
how we have to get the
is,
user database.
the thing is, you have to give encapsulation command. And you say PPP. Type this command. On all the ports, you have to give this command. Because you are doing PPP authentication, right?
Yes.
So you need to set the encapsulation first. If you don't set it, you cannot do authentication. Give this command.
Encapsulation PPP.
That's it. Now this router basic configuration is done.
Okay.
IP address, no shutdown, and encapsulation PPP, right?
Yes.
Now move on to your router 6 and do the same configuration, but on this side you will be doing what? Clock rate as well.
Clock rate. Yes, sir.
Okay. See this symbol. Can you see this symbol? This is the clock symbol.
Yes, sir.
Where you were seeing the clock symbol, this is where exactly you are configuring what?
Clock rate. Yes.
Okay, but make sure that you set up this command first.
Okay. Router 6. Interface. Zero slash 3/1. Oh. Here we have to write in encapsulation, right, sir? ये स्पेलिंग सही है ना? हेलो
सही है, सही है, सही है.
Clock rate 64,000. Shit. Interface.
You can do no shutdown.
IP address is not configured. Okay, 100.0.0.1, right?
Yes.
First of all, go to the port. Nicole. I guess you have already configured your IP address over here.
Yeah.
This one is configured, right? So move on to the next port. 0/3/0. Now this one is a DTE port, right?
Yes. DT port.
So simply just configure IP address encapsulation, give no shutdown command. The no shutdown command you didn't give in this port. This port is down. You can see that's 0/3/1. Give no shutdown command.
Simply type no shutdown and it will work.
It should be up.
Yes, sir.
So can you see this one is up now?
Yes.
Then move on to the DTE
Yes.
port and do the same configuration.
Hundred and one. Sir, here we have to we are doing the cap command. So we have to type encapsulation.
No, CHAP also comes under PPP only, no?
We don't use here. We don't type clock rate, right? Because
No. That you have to do in router 7. I think.
shutdown. Shit. Great. No shutdown. Exit. Okay, so these are all up.
Okay. Clock rate, you don't give it. You can go it. Before configuring clock rate, see this. This is the port, which is the DC, right?
Yes.
On this particular port only, you give the clock rate. When you give the clock rate to this DT type ports, you basically get this type of error messages. Okay, clock rate should be applied only to DC, not to DT ports. Now you can do the authentication. Start your authentication of PAP in between router 5, 6 and CHAP in between router 6 and 7. See the configuration.
Yes. Interface. Yes. Authentication. Sure. Sure. Exit.
Yes, Google.
Yes.
Which interface you are configuring?
Router interface SE0/3/1.
Okay, so there is a PAP configuration, right?
Yes.
Okay. Now send a ping from router 6 to router 5.
Success rate, sir. 100%.
Similarly, go towards router 6 and 7 and do the chat configuration.
Yes, sir. Sure. Yes. Slash. Exit.
Okay, success rate is 0%, right? Created the user database.
Yes, sir. Yes, sir.
The user database you have to create, right?
Created, sir, here.
Username router 6, password is 7. Okay. And on router 6, show me the router 6. Now here you didn't create the user database of router 7. Press enter. And that PPP authentication chap also you didn't configure, right?
I was able to ping the router 5, sir. Now.
No, from router 6 to router 7, we are having chap authentication, correct?
Yes.
So you have to configure this chap authentication in your serial 0/3/0, right?
Yes.
Click the user database first and select the chap authentication on this port.
Yes, sir.
User name will be router 7, password will be chap. PPP authentication. Okay. So now you should be able to ping.
Yes, sir. Yes, sir. Success rate 100%.
Success rate is coming, right?
Yes, sir.
Bhaskar.
Should I stop sharing, sir?
Yes. Bhaskar, can you hear me?
Yes, sir.
Is it working?
So for me, from router 0 to router 1, it is happening. 1 minute, I will share my screen here.
From router 0 to router 1 is working.
Yes, sir. So from here to here, it is working.
Unless which one? Tap is working. Tap authentication?
Sir, PAP authentication is working, so chat is not working. Sir, just
Tap is not working. Why it is not working?
so see here in router 1, I have configured this as well. See username router 3, password chat, interface S30, this interface PPP authentication chat, and then I exit from here, and then I went to router 3.
Just hold on. This is your router 1, right? On this
Yes,
port you will configure.
sir, 0/3/0.
Just zoom it a little bit. Okay. So show me the configuration of this port. PPP authentication tab. Username router 3.
Yes, sir.
Okay, so here is the username, right?
Yes, sir.
This is the same host name you have configured on router 3.
Yes, sir. See router 3. Okay.
See it properly. There is something wrong.
Okay, spelling alpha means okay.
I guess it is the case. Okay,
Yes, sir.
uppercase,
Yes, it is.
lowercase.
Yes, sir. Okay.
See that. This is your host name, right?
Yes, sir.
Check the host name on router 3. See what you have configured over there.
The router 3 it is in R is in capital letter.
So there is a mismatch. This
Case
is the host
sensitive.
name. Change the host name, or otherwise change the user database you have.
Okay. So should I change the host name? That
You
will
don't
be
have to change the host name. You can delete this user database. Just say no username.
okay.
Just add no in front of that over here. Go to the user database, global config mode, and copy that command from there. The user database command.
Yes, sir. Now I have to enter the each and every command, correct? After that,
Password is also correct, right?
yes, the password is checked.
Uppercase, lowercase.
No, sir, that doesn't matter.
See that properly. It is case sensitive. The username and password is case sensitive.
No,
Check,
sir.
check both the router's username and password informations.
Okay.
What username you have configured over here?
Yes, sir. I'm doing right, sir. Command correct.
This is, I guess,
Router
router.
3.
Username is wrong.
No, it will be a router 1. Sorry.
Go to the global config mode. Go to the global
Yes.
config.
Okay. Yes, and now it's working. So it's case sensitive is the issue, was the issue there.
You got it right?
Yes, and now it. Sorry.
Okay. So now, we'll just share. Okay, so the next thing what we are going to be discussing is this particular one technologies, everyone. This is your frame rate. Okay, this is the concept what we are going to be discussing now. What exactly you have is another type of connection. Okay, when it comes to WAN technologies, that is what we call frame relay connection. Okay, it's basically frame relay technology. What is available in WAN? It is considered as the cheapest one solution. Cheapest one solution in the sense that small organizations, small companies, okay, small sized organizations, they can basically afford this type of technologies because this line connection, what we are having, which just now we did the point to point connection, it is one of the costliest type of connection what we have available in one. Okay, when we talk about big organizations, they can basically afford this type of connection. But small organizations, they cannot afford a lease line connection because the price is huge. Okay, it's a very high price when it comes to one the point-to-point connection. So what we are having available over here is this one, the cheapest one solution, which is provided by Frame. Okay. This is your serial connection, what we are using, but the technology is different. So what happens over here is we have a frame relay cloud. This is what exactly is the cloud, which is ISP's infrastructure, which provides us the WAN connectivity. When we are connecting from one geographical location to other geographical locations, this cloud, which is basically made up of frame relay switches, routers, okay, these are all maintained by your ISPs. Okay. ISP from all the like what all countries, they are basically coming together and they are forming this particular infrastructure, what we are calling as cloud. And this cloud, it basically consists of thousands of like what routers, thousands of frame relay switches. Okay, what is used in order to provide connectivity to customers in the cheapest manner. Because not everyone can afford this point-to-point type connection, which is the costliest connection to maintain one connectivity. So what happens is when we use this type of connection, always purchase the exist. for maintaining connectivity. Okay, means to send information to receive informations, always this virtual circuit is used in the upper cloud. The switch what we are using is called a frame-based switch, and this switch only understands virtual circuit information. Okay. This is virtual again. Okay, it is not physical. A virtual circuit always is used in order to identify that from where to where we are doing communication in a frame-relay switch. Okay, because this switch, it is not like the switch what exactly we are using over here. These are Ethernet switches. Okay, these switches are Ethernet. You can see these switches. But this switch is a frame-relay switch. Here you can see all these ports. These are basically serial ports. All these are serial. And this is where exactly we are connecting our serial cable. And all these ports are DC ports. And always it belongs to the ISP. Okay. Always it belongs to the ISP side. So whenever we are using this type of switches, always these switches understand virtual circuit informations to perform forwarding of frames. Means whatever frames are coming from this HQ location going to this particular location, then always it uses virtual circuit information to forward the frame. So it is basically one-way path. One-way path means from HQ. So let's understand this topology a little bit. Here we are having the company's headquarters, which is located in US. Here we are having the company's branch, which is located in India and in UK. So we have two branches and one headquarter. And all these two branches, they are basically getting connected to the headquarter via this FR cloud. Okay. So whenever we are making communication from headquarter to India branch or UK branch, this is one virtual circuits are required. Okay. So to communicate from US to India, this is one way path. One way. Means you can use this virtual circuit to send information from US to India, but you cannot use the same virtual circuit to send information from India to US. It is not like this. One-way path means just think of it like a one-way road. Okay, in one-way road, you can only go in one direction only. You cannot come back by the same road. Okay, back to the source. You cannot like what you cannot do that. This one-way path is simply like this. You can use one virtual circuit to go from here to here only. You cannot use the same virtual circuit to come back in this direction. It is not possible. This virtual circuit is like that. Okay. Whenever you need to communicate from here to here, you need one virtual circuit. Whenever you need to communicate from here to here, you need another virtual circuit. Whenever you need to communicate from here to here, you need one virtual circuit. And whenever you need to communicate from here to here, then you need another virtual circuit. Okay. So one way path. This is what exactly this particular virtual circuit is providing you. Now, since these are virtual circuits, all these virtual circuits, it needs to be identified. And that is why exactly we're using this data link connection identifier. It is nothing but just a number. What exactly is being given by ISP to recognize the virtual circuit, which is used for making communication from one geographical location to another geographical location. So this data link connection identifiers always, it is like this numbers, you can see. Okay, these are the numbers which is basically used in order to identify the virtual circuit, which is used to connect from one location to another location. So these numbers are being provided by your ISPs, okay, because this entire infrastructure is maintained by your ISP itself. Now, whether your virtual circuit is up or down, okay, whether the virtual circuit is active or it is inactive. How do you know the status of it? If this virtual circuit is active, means it can be used to send information from US to India. But if the circuit is not active, then it cannot be used to send information. So this particular status informations, status of virtual circuit, you can get it with this local management interface, that is what we call LMI. This is nothing but a signaling method what we are using to know the status of your virtual circuits. We have three types of LMIs available. This is your Cisco, American National Standard Institute, NC, and Q933. This one is a proprietary LMI. Okay, specifically, it's a proprietary. And proprietary means what? Means you must have a Cisco router and you must have a Cisco frame relay switch. Both the devices must have, okay, must be Cisco. At the time only, you will get to know the status of your virtual circuits. Otherwise not. If this is a Cisco router and this is another company's frame relay switch, then you need to use this two. This two is open standard. Open standard means regardless of whichever company's routers and frame relay switches we're using, always you will be getting the support of it. So configuration of these, what like a frame relay, it is like what? 90% configuration, it is basically on the ISP side, you do it. Only 10% configuration you do it on your side. Only 10%. Because these are concepts of your ISPs, because they are giving us what like what one connectivity. So this infrastructure is ever cloud infrastructure. How exactly they're managing it with this type of switches? You can see over here that all the ports that have the DC symbol is also there. These are all DC ports. Means they are providing the clock rate to the customer. So what exactly we are doing over here is we have our network. You can see the network address 193.1.1.0. We are giving 193.1.1 on this particular port, 193.1.2 on this port, and 193.1.3 on this port. This is the IP address. But make sure, since we are using the frame relay technology, the encapsulation you need to set as frame relay. Make sure that you do this. On all the routers, the encapsulation, it must be frame relay. This thing you need to set. Encapsulation frame relay. Over here also we have to give, over here also we have to give, and over here also we have to give. Okay, because when you send anything to the frame relay switch, it needs to be encapsulated with frame relay encapsulation. Encapsulated frame. Okay, it needs to be encapsulated with frame relay encapsulation because your frame relay switch doesn't understand anything other than your frame relay. Okay, so all the frames, whatever we are sending from US to India, from US to UK, all those frames, it needs to be set up with encapsulation frame relay. Okay, so you can see the virtual circuit because we need a connection identifier to recognize the virtual circuits. This is the virtual circuit what we are using 101 to communicate from US to India. 201 we are using to communicate from India to US. Then from US to UK we are communicating using 103, and from UK to US we are communicating using 301. These are the connection identifiers, Delcy numbers. So configuration wise, what exactly we're doing on the router side configuration? Nothing. Simply we're setting up the encapsulation and configuring IP address, no shutdown. That's it. You set up the configuration on serial 0/3/0. You can see that you will configure the IP address and substitution is frame relay. No shutdown command is there. And this is the command by which you can change the LMI. Okay, if you don't want to use the Cisco LMI, then you can use the frame relay LMI type command and this answer. If you don't want to use NC, you can like what use Q933. All these are basically LMI types what exactly we are using. If you want to change it, that is the command by which you can change it. Take the screenshot of this. Taken.
Yes, sir.
Yes, sir.
If you don't want to change it, it means what? The default LMI will be what?
Cisco.
The default LMI will be Cisco.
Yes.
So these are Cisco routers, right? So default LMI type will be Cisco. Similarly, on the router 4 side, if we see show running config, you can see this is the configuration. And similarly, on router 8, see that? Configuration wise, there is nothing you are doing over here. Okay, because all the configurations, what we do, it is on the frame relay switch. So on the frame relay switch, what we are doing? First of all, we are going to the config. You can see that there is no CLI option as well. Normally, you get a CLI option, right? But there is no CLI because most of the things what exactly is done is in a frame relay switch. It is done using a GUI application. Okay, the GUI app. So you go to the config, and first of all, you select the port. Okay, so which port is connected to where? This is what exactly you have to make note of. So serial 1 is connected to US, serial 2 is connected to India, serial 3 is connected to UK. You have to know the virtual circuit, the LC number information over here. So US is using 2 virtual circuit in this direction. That is your 101 and 103. And both this is used on this port. This is your serial 1. Because this is the same port which is used to receive the traffic for India and UK location from US. Because whenever this machine is sending anything for India or UK, everything is coming on this port only, serial 1. And on this port, we are assigning this 2 virtual circuits over here. So how do you assign your virtual circuits? So you simply just click on this serial 1, and you can see that you are getting 101, that is US to India, and 103, that is US to UK. Okay. Once you give this, you press it. Okay, so you can write the virtual circuit, the name, and end. See the element type and see it. Similarly, on serial number 2, we are using 201 virtual circuit to communicate from India to US. So this is the 201 virtual circuit India to US. You can see that Cisco we are using default LMI and it on it. On serial number 3, we are using 301 virtual circuit to communicate from UK to India, UK to US. So this is the one which I'm about to modify a little bit, UK to US, and hit on it. So this is the virtual circuit. This is what we call DLC assignment. DLC assignment. Assignment to ports. Because unless you are assigning your DLC numbers to the ports, your friendly switch cannot understand that which particular virtual circuit should be used to communicate to what. So this is the main thing. This is the first thing what exactly you need to do. Assign this. And later you have to set up the connection. Okay, so this is the from section. is the from section, and this is the to section. So this from means source, and this to means destination. So from which particular location traffic is coming, to which location it is going, which port should be used to receive the traffic, which port should be used to send the traffic to the destination, which virtual circuit should be used to receive the traffic, which virtual circuit should be used to send the traffic. This is what exactly the connection what we are defining over here. So first of all, let me remove all these things. Now from here, use the drop down. First of all, we are communicating from our location to India location. So this is the virtual circuit we are using on this port, and this is the virtual circuit we are using on this port, serial 2. This is what we need to define. So we select serial 1 and we select this one. So this one is US to India. You can see that US to India is coming. This is your virtual circuit 101 and serial 2201. So select serial 2 and you can see that India to US. India to US, that is your 201 virtual circuit. Click on it. It is that. Then we are communicating from serial in this direction. So to communicate in this direction, we are using 103 virtual circuit, and from here 301. So 103 is getting used to one on serial 1, and serial 3 is getting used on serial 3. So simply we are defining this thing over here. So select serial 1 US to UK. That is your 103 virtual circuit, and select serial 3 UK to US. That is your 30, and click on it. So once you have added this virtual circuits informations, try to ping from here. Show before show giving the verification, let me ping the address 193.1.1.3 and 1.1.2. We're pinging from the HQ location to our India location. So 193.1.2. Can you see success?
Yes.
And
Yes,
this is
sir.
our UK location 193.1.3. See that success is there.
Yes.
Now there is a verification command which you can use. Two verification commands are there. One is the show frame relay PVC. Okay, PVC basically stands for permanent virtual circuit. Okay, permanent virtual circuit. This PVC command, if you give, you will get to know that which virtual circuit is used to communicate on serial 0/3/0. What type of interface you are having? Then what is the status of this virtual circuit, whether it is active or inactive? Now, all these informations we are getting it by using this command show frame PVC. But if I want to check the LMI, then I will use the show frame relay LMI command. And this is one exactly. You can see, can you see the LMI type is NC on this port? The type of the port is what? DTE, right? And this is the statistics. Okay. So this LMI is used for what purpose? It is used to know the status of a purchase circuit. So this is status. This is status means what? Whether it is active or inactive, Can you see number of status inquiries sent? Can you see this value?
Yes, sir.
And can you see this value, number of status message received?
439.
This value always it is less than one of the status inquiries, always. Because on a periodic interval basis, we send inquiries to know the status of our purchase circuit, which is active or not. If I give this command again, you will see that this number is increased. So right now, if I give this command again, can you see it is 441 now? Earlier it was 436, right?
Yes,
Right now
sir.
it is 441, and the status message is what? 440.
440.
Okay, less than one of the status inquiry sent. Because on an interval basis, this router is sending status inquiries. Okay, so LNI status inquiry. Inquiry. Now, why this inquiry is being done? It is basically to know the virtual circuits which we have 101, 201, 103, 301, all this. To know the virtual circuit's status, we are having. Okay. So it is constantly sending this type of inquiry message, and this friendly switch is replying with the status message. Status message. Okay. So status message are nothing but just the reply message in order to basically inform the US router that whether the virtual circuit is up or down. This is what we are having. So configuration wise, there is not much configuration what you do on your router. These are basically configurations what you were doing on your frameless switch. Okay, because this is a frame relay switch configuration what ISPs they are basically using. Understood?
Yes, sir.
Yes, sir.
Sir, one question, sir.
Tell me.
Is this the basics of cloud computing, sir?
No. This is not weird. This concept is different. Okay. What we are having over here is a technology which lets you connect from one geographical location to another geographical location at the very cheapest possible live what rate. Because everything involves money, right? When you take an internet connection, you have to pay your ISP. And when we talk about this type of connection, pay is huge. Okay. This type of connections, you have to pay a very huge amount of money. Okay, because these are dedicated connections coming directly from your ISP router back to your router. That is why exactly this type of connection cannot be afforded by a small organizations. Okay, and this is the reason we are using this particular uh, one technologies over here. Okay. So cloud concept is coming, but the thing what we do on cloud that is we provide services. You can compare it with a cloud service, but the main idea over here is to connect multiple locations of an organization at the very cheapest way possible. Okay, using the frame in the cloud concept. Understood?
Yes.
Okay, everyone. So do all these things. In the next session, we will be having the switching technologies. Okay, we'll be discussing about something called VLAN, inter VLAN. All these things are coming. Okay, so the routing section is over. And what exactly we'll discuss there is your switching technologies in the next session. Okay? So I will see you guys in the next session. Bye and take care all of you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.